Hello everyone, I am Sidhu. I am having 7 years of experience as a software developer. Today we'll discuss about Langchain. This course is provided by Microone. If you don't know Microone yet, Microone has world-class software engineers. Platform is provided by AI. They connect the best software developers in the world with top companies. They have robust interview process and compliance process that makes the hiring breeze. Let's come back to the presentation. We'll discuss about Langchain. What is it? Why do we use it? How does it work? It's an open source framework that allows AI developers to continue, combine LLMs like GPT-4 with external sources of computation and data. You can write code in Python and TypeScript. After the introduction of GPT-4, this framework is exploding. Why LangChain? ChatGPT or GPT-4 has a exceptional knowledge. You can ask anything, you will get pretty good answer. Own data, book, or any property info. We are not talking about snippets or parsing data. LangChain help you to take the action you want or take the instance of sending an email with some specific information. And user asks initial question to LLM. A vector representation of that question is used to do a similarity search in the vector database. This allows us to fetch the relevant chunks of information from the vector database and feed that long-ways model as well. Now the long-ways model has both the initial question and the relevant information from the vector database. Therefore, it's capable of providing an answer or take an action. A link chain helps build applications that follows a pipeline like this. In LangChain, there are three main concepts: components, chains, agents. Let's coming to the components. Component contains LLM wrappers, prompt templates, indexes for relevant information written. Coming to the chains, chains is a assemble components to solve a specific task such as finding info in a book. Coming to agents, agents allow LLMs to interact with its environment. For instance, making an API request with specific action. In a high level, LangChain contains models, prompts, chains, embedding and vector stores, and agents. Let's move on to the demo of LangChain, some of the functionalities. We will move on to the chart model. GPT 3.5 or GPT-4 are chart models. In order to chart with a chart model, we need to import a schema consisting of three parts in LangChain: AI message, human message, system message. If you see now, I'm importing a schema as well as importing AI message, human message, system message, as well as actually I'm using chart OpenAI and using the model name as GPT 3.5 Turbo. And I'm sending system message as you are an expert data scientist, and human message as write a Python script that trains a neural network on simulated data. You can see that resulted in some information. As well as you can use the prompt template in LangChain as well. Prompts are what we are gonna send to the language model, but most of the time those are not going to be static, and they are dynamic prompts as well. So it takes piece of text and inject user input that to the text we can feed to the LLM. So if you see now the template containing concept, we kept it in the braces. We would like to pass this concept as a dynamic prompt instead making it static. And if you want to make, like, if it is a single line of code, it's easy to do it manually, but if it's like thousands of prompts, instead doing manually, we can use this prompt template langchain functionality to send as a dynamic values. I'm sending auto encoder value as a dynamic value. You can see now it passed as an auto encoder and it's giving us some meaningful value. So let's go to the chains. So here, if you see now, I'm importing a LLM chain to define chain with language model and prompt as an argument. Here you can pass, you can create one chain, you can create another chain, you can inject another chain as first chain's input so that we can make it a simple sequential chain as well. If you see now, a language chain has a chain I created as a chain 1, and here I created a chain 2, and here using simple sequential chain, I passed the first chain as the input to the second chain. I made it a sequential chain here. I'm going to share this notebook with everyone so that easily you can copy paste and practice this information. Then let's come back to the vectorization. So I'm going to take this text, this complete text actually, and I'm going to split it up into chunks. How chunks? Actually, LangChain has a text splitter functionality inside, like recursive character text splitter. I'm going to use that. My chunk size is 100. So if it has a 500 characters, it is chunking into 100 chunk size wise. Because we want to store it in a vector store in Pinecone, Langchain has a text splitter tool for it. We can extract the plain text of individual elements of a list with the page content. So I'll open the Pinecone right now. Pinecone is a free vector database and vector search tool for one index. If you want more indexes, you need to buy for it. So as I'm using a free tier, I created a one index. I'll show you how it is. So here, this is the index I created. So these are the API keys you can create. And I created an index for the text. I split up into chunk sizes, and then actually I'm checking whether whether the chunk is there or not. And then I'm using model name Ada from OpenAI embeddings. I'm using OpenAI embeddings as a function, and then I'm using embedding dot embed query of this page content. It created now the vectors actually, and then I'm using pinecone from Langchain. I'm passing my environment and API key and initializing it, and then if I'm doing pinecone dot from document of the text and embeddings, right, and I'm passing the index name as micro1 because I created this micro1 as an index. And then what it does is internally, if I open this, when you run that command, all these vectors, whatever you are seeing here, these vectors got stored in as a 10 vectors here. You can see now. Now, after that, what I have done was I just wanted to run a query on top of it just to see the similarity search. So I just typed like, what is the magical about encoder? And I ran this query and it gave me the answer. And it came out of this similarity search text. So now we learned how to split it, how to convert the chunks into vectors, and then how to store the vector into Pinecone database. As well as we can see the agents as well. If you see now, I am using the Python agent just for the example purpose. And then this agent has been created. And then I'm using this agent, I'm running like find the roots if the quadrants function of something. And it's trying to execute this. So Langchain has variety of functions, variety of agents. Even Langchain gives you SQL agent as well. In the next session, we will see how can we connect our database using Langchain SQL agents. That's all for this session. Thank you.